Alright, so let's try this one out. We have a 12-foot pole and a 28-foot pole. They are 30 feet apart. We want to stretch a wire from the top of this one down to the ground, and then from there to the top of this one, and use the minimum amount of wire to do that. Okay? Obviously there's lots of different amounts you could use depending on where you had the wire attached to the ground. So we want to find the least amount of wire to use. Okay? So let's see. We probably need to start by writing an equation to represent the amount of wire you're going to use. Because you want to have an equation that you can maximize or minimize. Okay? So that's where the textbook is saying, well, let W equals Y plus Z, where they call this amount of wire right here their Y amount. They call this amount of wire Z. So the total amount of wire we're going to use is Y plus Z. And that's the function that we will want to minimize eventually. But in order to minimize it, you will want that function to be written in just one variable and not two. Okay? So it's very similar to some of the other setups that we've done. Alright? Since it's 30 feet across and these distances could be varied, you know, because you bring the wire straight down here and then up, this distance could be varied. The book decides to call one of them X. And then, therefore, since it's 30 feet all the way across, the other one would simply be 30 minus X. Alright?
Wait.
That makes sense.
So if this was 10, 30 minus 10 is 20, so then you have a 10-foot area and a 20-foot area and so on. Okay? Alright. So, if we want our equation that we're going to minimize to be written in just one variable, okay? In the past, we've changed one of the variables to match the other one, or vice versa, right? Okay? Going to be a little tough to do here. How are you going to write Z in terms of Y when Y is part of this triangle but definitely not part of that triangle?
So maybe set it up as, oh wait, I have them flipped. 12 squared plus x squared equals y, y squared, and then 28 squared plus 30 minus x squared equals z squared.
In a nutshell, we're going to rewrite Y in terms of X and write Z in terms of X. Therefore, both of them will just become in terms of X, and then we can differentiate from there. Okay? We have right triangles.
True that.
Because we have right triangles, we can use Pythagorean's theorem. Pythagorean's theorem would say 12 squared plus x squared equals y squared.
Bless you. Thank you. You're welcome.
So therefore, y would equal the square root of this side. So 144 plus x squared.
Yes.
So y would equal this amount, whatever that is. And we can do z similarly. Z squared would equal 28 squared plus 30 minus
Outside, right? Yeah.
30 minus x quantity squared.
So would we want to FOIL that out?
I think so, because I just think keeping the expression underneath the square root would be easier if it were not within another set of parentheses.
So 784 plus x squared.
28 squared was that 784?
Yeah, that's what I got.
Okay. And then if you FOIL 30 minus x times 30 minus x, 30 times 30 gives us 900. 30 minus x times 30 minus x, so minus 30x plus x squared. So minus 60x plus x squared.
Is the x squared inside too?
Why
or
not
did you
just-
cross that off?
No, I crossed that off. Yep, that's not there.
Okay.
So then, z squared would equal 1684 minus 60x plus x squared. That's really bothering me writing it that way.
Let's
Then over
put
here
it
too.
as x.
And then if you square root it,
60x.
z would equal the square root of x squared minus 60x plus 1684.
So you have to go in order?
Gotta go, well, I just like having it in order, it doesn't
Same.
matter. But, okay? So I'm gonna go to the next page. So we have y equals the square root of x squared plus 144,
Yes. Yeah.
and z equals the square root x squared minus 60x.
Yes. Plus 1684.
And we know w equals y plus z, right?
Yes. Plug it in.
Yep. So then we can substitute.
And then would we just find the derivative of that and then find the maximum and
We want to use the minimum.
or yeah,
because
because
we're
we're
trying to find
finding
the
the
minimum amount
smallest.
of wire that we could potentially use in this situation.
And then would we also want to raise it to the half power instead so that
To
it's,
do the derivatives, yep.
yeah.
Yep.
So I'm actually gonna do that now. Let's go general.
If you think of this being raised to the half power, the derivative of that would be 1/2 x squared plus 144 to the negative 1/2 times 2x.
Yes.
Because you got to take a times the derivative of what's inside.
And then half of x squared minus 60x plus that to the negative half power. And then 2x minus 60?
Yep.
Let's simplify.
It's a pretty good guess.
I like simplifying.
The 2x, excuse me, yeah, the 1/2 times the 2x will just give you x, so I'm going to have x over the square root of this.
Yep.
Uh-huh.
Would you put it back into roots?
And then would
I
you,
am because I don't want to deal with the quantity raised to the half power. I think it's going to be easier to solve when it's back in the radical form.
would you do the same with the second except it'll be x minus 30?
Yeah. So 1/2 times 2x minus 60 would be 1x minus 30, or just x minus 30. So x minus 30 on top, and then the square root of this on the bottom.
Uh-huh. Would we want to make it common denominator so it's easier to see when it's positive or negative, or would you suggest us plugging it in? Because that would be a lot of work making that common denominator. Well, would it? I don't know. Yeah.
So we want to know when this equals 0. So we have to set that equal to 0.
I think it would almost be easier setting it common denominator and then going off of the numerator, double checking to see if putting it in the denominator makes it illegal and then doing that, but that seems like a lot of work.
It just
I
says
agree.
plug in 0. Set it equal to 0 in the book.
Mm-hmm. I was trying to think what's going to be the quickest approach to solving it when we set it equal to 0.
What other approaches do we have?
I mean, maybe you could
Seven different.
move one of them over to the other side and do some sort of cross multiplication.
Done. This is it.
But doing the cross multiplication, isn't that rather similar to...
It is, yeah.
Oh, pay someone smarter than you. Like me. I'll do it.
So you just finish this problem and we'll all be done.
John, they can do this from here.
Yeah, I can. Mr. A, do you have
Oh, yeah.
Kleenexes in there?
Right up here.
Oh,
Give John the marker, let him do it.
Yes, that's the first.
A little bit.
Plus, once it is together, then it'll be easier checking left to right.
Buck's got a different strategy that I didn't think of.
Cry, not.
No.
I like that one.
So they set it equal to 0.
Yeah.
Moved one of the terms over to the other side, and then squared both sides to
Oh.
get rid of the radicals.
I guess that works.
that's what I was gonna
Said
do.
it earlier.
What's that?
I said that.
You said square both sides? Yeah, as long as you can get it to where you got
That earlier.
one term on one side and one. You won't want to square both sides now. Yeah, you could. Yeah, have fun with that. Okay, but you could square that right now. You have to foil it in a sense. That would be
I would not
Ugly.
want to do that.
okay.
You ugly girl.
So do we want to see
Yeah.
this?
You
Yeah,
better do
why
it.
not?
Okay.
Oh, wait.
We can count dribbles. I really want to count dribbles.
All right. So I set that equal to 0,
You wanna go to the game?
and then if I move, okay, if I move one of the terms over to the other side, it would make that term negative.
Yes.
Could you rewrite all that thought? But if you square it, won't it go back to white?
So we're doing it, you do it.
So we have negative x
Plus 30 over whatever it is now.
Nope.
Oh, you're doing that one over. Okay.
So if I move this one over, I have to subtract it. So that would give me negative x over that. And then I have
X minus 30 over the square root of x squared minus 60x plus 1684.
Yes. Yes. Yes.
You are the smartest kid I know.
Amen.
alright,
I'm
okay.
flattered, but you're probably not.
Alright, okay. Then you could square, or you could do cross products and square both sides. So you'd have negative x times the square root of x squared minus 60x plus 1684 equals x minus 30 times the square root of x squared plus 144.
That's practically the same as
Right.
setting it.
And then,
Okay.
do it your way, that's fine. Then I'd square both sides, okay? And by squaring it, you're squaring a product, so you're squaring both terms. So you get x squared times just that quantity itself. And then you'd have
Let's
Okay,
do
can
some
you-
distribution.
how did we what now?
Maybe.
Sorry?
Oh, you cross my.
Oh.
Yeah, to go from here to here, I just cross multiply, because we have a proportion.
Are we gonna foil that?
Okay? We're going to take the book's answer and write it down, so we don't have to foil it.
Oh, come on.
Cheating.
So we did on a tester.
Yes, we get.
So, x to the fourth
You only have to show your calculator.
minus 60x to the third
This is all algebraic.
plus 1684x squared.
How are you gonna
Now you'd have to,
Well, you use your phone for that.
you have to take this times itself twice, so x minus 30 times x minus 30, and then take that answer times this.
Good God.
We're just gonna use the book.
I mean,
Which,
it's just
we're just gonna go
tedious.
ahead and use the book. And say
Using our resources.
x to the fourth
I'll use my resources on.
minus 60x cubed
Wolf and Alf.
plus 1044x squared minus 8640x plus 129,600.
Plus I'm trying to.
Holy crap.
Oh my.
Wait, how did we get the x? It wasn't negative, you know? And now
We squared both sides. And when we square the left side, you're squaring the product. So like if you would take a times b and you would square it, you'd get a squared times b squared. So when I square this side of the equal sign, I have this squared, which negative x times negative x would be x squared. That good then?
Yep.
Okay.
Did you feed him?
Then let's set it equal to 0.
Is that plus 129,600?
Yep.
Yeah.
So if you subtract x to the 4th from both sides, those are gone. Add 60x cubed to both sides, those are gone. Subtract the
Oh, you can do that.
negative, or subtract 1684x squared from this,
Wait,
be
how?
640, be negative.
Wait. How do the 60, negative 60x is around?
These cancel, if I add 60x cubed to both sides, be zeros there,
Yeah.
Job field.
okay? Then I still got my negative 8640x plus 129,600. Then if I were doing this on my own, I'd start dividing them by 10, then maybe I'd start dividing it until I got this down to simplest terms.
Try 320.
Okay? The book says I should try 320. That's how to guess. Yep. Or actually, in this case, negative 320. So that would leave me with
Nah, but that's possible.
2x squared
Minus.
That's one thing I got.
But that squared.
I mean, I guess you can use the book
plus
for
45 minus 18,
No,
that'd be 27.
Home stop. It's not as important.
Yes, it is.
And then 9 times, or 405.
Feels like cram right
Okay? Yeah, the book's even skipping a ton of steps here.
Let's do that.
Well, they're just then factoring for us.
And then when you factor it, looks like you get, alright guys, come on. X minus 9 and 2x minus 45. Set both factors equal to 0.
divide by negative 320.
If you set both factors equal to 0, you can set that equal to 0, doesn't do anything. Set that equal to 0, you get 9. Set that equal to 0, you get negative 22.5, which is not relevant in the story problem. So the only critical point we get is x equals 9.
So then we can set 9 equal to our x and then plug it back in.
Just for.
I could
And
have
then we
guessed.
can
not
find the
fast.
hypotenuse.
Got that right.
Faster than
You could have, yes.
We can put it
So therefore, x is 9.
Oh, geez.
30 minus 9, this would be 21.
21.
But remember the question was find the minimum amount of wire. So figure out how long the y value of wire is, and then figure out how long the z value of wire is by plugging in
I
9.
got 15 for y.
Correct.
Like, I'm not even mad about it. I'm just a child.
So, answers.
So when we guessed 10 right at the beginning, we were
Right.
I got
close.
50.
We were close.
So we should have just stuck with our guns.
We were close, yeah.
I got 50.
Wire. We don't even
Does 50 work?
Huh?
50?
Yes, it does.
Well, that
As
would
in
be, is this 15?
Yeah, 15, and then that's 35 to equal a total of 50.
So 50 feet of wire is the minimum amount you could,
Wait, how'd you know? You put it
if this is 9, 9 squared plus 12 squared equals y squared, figure out Pythagoreans.
9.
Same thing
Or
here.
not 9, sorry.
Use Pythagoreans, figure out z, add them together.
35.
This is 15, this is 35, we're wasting time, you're loud on the video, okay? 15, 35, so it ends up being 50 feet. Alright? Any questions how I got there?
Nope.
We miss you, Kyle.